So factoring polynomials really is the opposite of expanding or distributing polynomials. So when we distribute a number, what we're doing is we're eliminating the brackets. When we're factoring, we are creating brackets. All right, so to give you an idea, we've been learning how to do something like this. 2 multiplied by x plus 5. So we learned to do that. We multiply the 2 with the x, the 2 with the 5, and we end up getting 2x plus 10. This process, taking an expression written in this way with brackets and changing it into another expression that is exactly the same only without brackets, is called expanding. Okay? When we go backwards and when we take this expression that has no brackets and creates an equivalent expression that has brackets, what we're doing is we are factoring. All right, now this idea of brackets versus no brackets, really what it means is, we're changing an expression that's written as the sum or product of terms. So this expression here, 2x plus 10, that's two terms being added together. Okay? When we're factoring, we're changing this from an expression where two terms are being added to an equivalent expression where two terms are being multiplied. And in this case, the two terms that are being multiplied would be term 2, which is a monomial, being multiplied by this term here, our second term, which is a binomial. So it's 2 multiplied by x plus 5. All right, and so that's what factoring is. We're changing an expression from the sum of terms into the product of terms. All right, and this is really, really helpful, especially when we start looking at quadratic relations. We'll look at that in the next unit. Now, whenever you need to factor a polynomial, and there's lots of different ways we're going to learn how to do this. Today we're just looking at one way. Whenever you need to factor a polynomial, you always have to look for what's called a common factor. All right, so let's get into what that is. So first of all, the definition of a factor. A factor is a number that goes into another number evenly. So what that means is we can divide the larger number by the smaller one to get a remainder of 0. So for example, if you were to ask yourself, is 2 a factor of 6? Is 2 a factor of 6? Well, can 2 go into 6 evenly? Well, yes, it can. 2 goes into 6 3 times. Another way of thinking about that is we can take 6 divided by 2 and get 3 with a remainder of 0. Okay? But if we were to ask ourselves the question, is 4 a factor of 6? And the answer to that question is no. 4 can't go into 6 evenly. 4 goes into 6 once, but it can't go into 6 twice because 4 times 2 is 8, not 6, right? So thinking of it this way, 6 divided by 4, does not give us a whole number quotient, right? It gives us a decimal value or, a whole number with a remainder, okay? So 4 is not a factor of 6. So when we're writing out factors, what we need to know about the factors of certain numbers is we need to know our multiplication tables, right? So for this example, let's write out all the factors of the number 18. So to find the factors of 18, write all the numbers that multiply to 18 in order. That's important. So you might remember having done this in middle school, maybe even earlier. All the factors of a number, 1 is always a factor of every number because 1 multiplied by some number gives you that same number, right? So 1 and 18. And sometimes you connect them with little lines like that, right? And we'll put a comma. We go to the next integer after 1. 2. Is 2 a factor of 18? Well, yes, because 2 multiplied by 9 gives us 18. Is 3 a factor of 18? Yes, because 3 times 6 gives us 18. Right, and now you should start noticing the gap between numbers starting to shrink, right? 3 and 6, Is 4 a factor of 18? No. Right? I can't multiply 4 by anything to get 18. Is 5 a factor of 18? No. And now 6 we already know is a factor of 18 because 6 times 3 gives us 18. So our factors of 18 are 1, 2, 3, 6, 9, and 18. All right, so those are all the factors of a particular number 18. The greatest common factor, if you'll remember, is the biggest number that goes into 2 other numbers evenly. Right? So if I gave you 2 sets of numbers, we could write out the factors of each number and find the greatest common factor. Right? That would be the factor that is the same in both groups, that is the largest number. So let's try this out. The greatest common factor of 36 and 48. Well, the factors of 36, 1 and 36, 2 and 18 give us 36. 3 and 12, 4 and 9. Now 5 is not a factor of 36 because 36 is not divisible by 5, but 6 is a factor of 36. 6 multiplied by 6 gives us 36, so we're just going to write one of those 6's there. So the factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36. The factors of 48. So we're working on the factors of 48. Okay, so 1 and 48. Okay, then 2 and 24. Okay, now 3. Is 3 a factor of 48? Well, you'd ask yourself, is 48 divisible by 3? You can use a calculator here to check, but 48 is divisible by 3 because if we add the digits in 48, 8 plus 4 give us 12. 12 happens to be divisible by 3, right? So to figure out 3 multiplied by what number gives us 48, we'll do a little division here. 3 goes into 4 once. Bring down the 8. 3 goes into 18 6 times. So 3 times 16 gives us 48. Okay, now the same thing with 4. Okay, so 4 multiplied by what number gives us 48? Again, we can do a little division there. Right, 4 goes into 4 once. 4 goes into 8 twice, so 4 times 12 gives us 48. 48 is not divisible by 5. 48 is divisible by 6, though that would be 6 multiplied by 8 gives us 48. So those are all the factors of 36 and all the factors of 48. Now you'll notice there are common factors here. 1 is a common factor, 2 is a common factor, 3, 4, 6 are all common factors. 12 is, and that's it. Now the greatest common factor here, right, would be the number 12. The factor that is the largest factor that's the same in both groups. Now another way to think about this is to find the greatest common factor of 2 numbers. Start thinking about numbers that divide evenly into the given ones, right? Like 36 and 48 are both divisible by 2. But there is a larger number that we can divide both of those by. We can divide both of them by 3. We could also divide both of them by 4 and by 6, but the largest number that we can divide both of them by is 12. And so that's important. All of these other factors are divisible by both of these, but we're always interested in the largest number that is divisible by both of those numbers. Okay, now the greatest common factor for polynomials, for 2 polynomials, could be a variable, a constant value, or both, and that's really important. Okay, let's try this example here. We have 2 polynomials, 18x squared and 9x. So I'll write these out. 18x squared is my first one. 9x is my second one. Now what I'll do is I'll start by writing the factors of 18. 1, 2, 3, 6, 9, and 18. Those are all the factors of 18. And I'll also write all the factors of 9. This is a lot smaller of a group. So 1, 3, and 9. These are the only numbers that are divisible by 9. However, both of these terms also have a variable. This one has a variable x squared, and this one has a variable x. The way you need to think about this, x squared is the same thing as an x multiplied by another x. So there are two x's being multiplied together to give you this one. Whereas 9x only has a single x. So now when you're looking at the greatest common factor, take a look at the largest number that's common to both groups. So in this case it would be 9. And then also take a look at how many variables are the same in both groups. So this has two x's, and this has a single x, which means that a single x is common to both groups. So the greatest common factor here would be 9x. Okay, so thus far all we've been doing is finding factors and greatest common factors. We haven't yet factored a polynomial. And so to do that, here are the steps. So to factor polynomials using common factoring, the first thing you want to do is to determine the greatest common factors of all the terms in the expression, including the greatest common factors of the variables. Now you don't have to write these all out if you know your multiplication tables, and I'll show you what I mean by that. Number 2, write out the greatest common factor, then open up a set of brackets. Now what's important here to know is that if your first term is negative, your greatest common factor must also be negative. And then what you're going to do is divide each term in the original expression by the greatest common factor and put the results in a bracket. Okay, so let's try this process out. Example 4a. So what we want to do here is factor the following polynomials by common factoring. Now, I'm not going to write out all the factors. Instead, what we'll do is we'll look at these two terms, 10x and negative 15, and ask ourselves, what's the largest number that we can divide both of these by? So 10 is divisible by 2, but 15 is not divisible by 2, so 2's out. 3, 10 is not divisible by 3, 15 is, 3's out. We need a number that divides evenly with both of them. 4 doesn't work with either of them. How about 5? So 10 divided by 5 works, so does 15 divided by 5. So 5 is our greatest common factor. Now let's look at the variables. This term has an x, but this one doesn't. So x is not common to both. So the greatest common factor is just 5. We open up a set of brackets. Now inside the brackets have to go two terms. To get those two terms, we divide each of these terms by the greatest common factor. So 10x divided by 5 is 2x, and negative 15 divided by 5 is negative 3. And so there we have it. 10x minus 15 is the same thing as 5 multiplied by 2x minus 3. You could always check by expanding. 5 times 2x gives us 10x. 5 times negative 3 gives us negative 15. Okay, so that's really just the entire process. Now, you get a little bit of a twist here when your first term is negative. If your first term is negative, your greatest common factor must also be negative. So in this one here, negative 12x squared plus 20x. You know, thinking about for now the 12 and the 20, what's the largest number we could divide 12 and 20 by? Well, 4 works, right? 4 looks like to me it's going to be the biggest one. Because the first term is negative, our greatest common factor is going to also be negative, so negative 4. Next, we'll look at the x's. This one here, x squared, there are two x's being multiplied together, x multiplied by x. And this one here has only one x. So there are x's common to both groups. How many are common to both groups? Well, just one. So x is also a greatest common factor. So our greatest common factor here is negative 4x. We open up a set of brackets, and now we divide. So negative 12 divided by negative 4 is positive 3. Now x squared divided by x. We had two x's here being multiplied together, but we took one of them away. So what's left is just a single x. Okay. And now 20 divided by negative 4 is negative 5. Now we had this x, but we took it away, so there should be no x here. Negative 4x multiplied by 3x minus 5. Okay, a few more examples. C and D are fairly straightforward examples. Let's try these ones out. So for C, we have a trinomial that we want to factor. So we have 3, negative 9, and 12. The greatest common factor between 3, negative 9, and 12 is going to be 3. And x's, there's an x squared in the first term, an x in the second term, but no x in the third term. So what we need, in order for x to be a common factor, we need x's to be in all three terms. There are no x's that are common to all three terms. So 3 is our greatest common factor. Open up our brackets. And now we'll divide. 3x squared divided by 3 is just x squared. Negative 9x divided by positive 3 is negative 3x. And then 12 divided by 3 is positive 4. Okay, a similar one here, D. The only difference with this one is our first term is negative. But if you'll notice again, x is not common to all three terms. Here we have two x's. Here we have only one, but here we have none. So the greatest common factor here, the number that divides evenly into 10, 20, and 30 would be 10. But because the first term is negative, we're going to make our common factor negative 10. Open up a set of brackets. The three terms that go inside are obtained by dividing. So negative 10x squared divided by negative 10 is just x squared. Positive 20x divided by negative 10 is negative 2x. And negative 30 divided by negative 10 is positive 3. All right, and that's our factored form. Now, E and F are two other examples that I thought to show you, but they are a lot more complicated, and we don't usually see examples like these ones in our coursework. Now, I'll show you how to do them anyways, just to extend a little bit. So this one here, 24x squared minus 18x cubed plus 36x to the exponent of 4. What's challenging about this one is that we have exponents on our x that are larger than 2, but we do this the same way. First, let's look at our greatest common factor between 24, 18, and 36. The biggest number that we can divide all three of those terms by looks to me like it would be 6, I believe. Looks like it's 6, right? So 24 is divisible by 6, 18 is divisible by 6, and 36 is also divisible by 6. And that would be the largest number. So let's write that out, 6. Now let's look at our x's. The first term is x squared, so that's x times x. The second term is x cubed, x times x times x. And the third term is x to the exponent 4. 4x is being multiplied together. So how many x's are common to both groups? Another way to answer that question is, what's the largest number of x's we could remove from all three of these groups? Right? Like this group has 3 x's. And I can take 3 x's away from here, but I can't take 3 x's away from there. So the largest number of x's that I could remove from both groups is 2 of them. So that means my greatest common factor is x squared. Open up a set of brackets. 24 divided by 6 is 4. So 24 divided by 6 is 4. X squared divided by x squared is 1. So the 2 x's that we had, we took both of them away. So no x's left. That's just 4. Next term. Negative 18 divided by 6 is negative 3. Now x cubed divided by x squared is just x. And we can see that because we had 3 x's together being multiplied, but we took 2 of them away, so only 1 is left. And now lastly, 36 divided by 6 is 6. X to the exponent 4 divided by x squared is x squared. 4 x's being multiplied together, took 2 of them out, we're just left with 2. All right, and so that's the factored form of this one. Now this one here is another interesting one because in addition to exponents higher than 2, we also have another variable. We have y. Well, this is done the same exact way. Let's look at the coefficients first. 3, 27, and 18. The greatest common factor between 3, 27, and 18 is 3. Right? The largest number that we could divide both of them, all 3 of those by, is 3. Because the first term is negative, my greatest common factor is also going to be negative, so negative 3. And now looking at the variables, x cubed y squared, that's x times x times x times y times y. And this one, that's x times y. And this one here, x times x, 2 x's, y times y. Now let's look at the variables. What's the largest number of x's I could remove from both groups? Or from all 3 groups? Well, that would be 2. I could remove 2 x's, 2 x's, 2 x's. And what's the largest number of y's I could remove from both groups? Just a single y. Y, y, y. So my greatest common factor then, it's negative 3, but it's also x squared, and it's also y. So I got my greatest common factor. We'll open up a set of brackets and we'll divide. Negative 3 divided by negative 3 is 1. X cubed divided by x squared is just x. Y squared divided by y is just y. Negative 27 divided by negative 3 is positive 9. We had 2 x's, but we took them all away. We had a single y, and we took that away, so no variables here, just positive y. And then finally, 18 divided by negative 3 is negative 6. We had x squared, but we took x squared away, so our x's are gone. We had y squared, but we just took one of those y's away, so we're just left with 1y. And there it is. This is going to work out to be negative 3x squared y multiplied by 1xy plus 9 minus 6y. All right. Now, I just want to be very clear. These kinds of examples, E and F, okay, are sort of advanced examples. We're not going to be seeing any of these in this course. All right. I just wanted to show you those as an extension to what common factoring is. The last thing that I want to show you today is an area problem. Okay, and you see these kinds of things a lot. And in order to solve it, really what this involves is factoring. Okay, just factoring. So let's try this one. It says the area of some basketball court is represented by this binomial, 4x squared plus 28x. So a basketball court is a rectangle. Right? What we are given is the area, but we're not given the area as a number. We're given the area as an expression. The area is 4x squared plus 28x. What this question is asking us is to determine expressions for the length and width of the basketball court. Now, for any rectangle, area is given as length times width, right? So we know what the area is. The area is 4x squared plus 28x. What we want to determine is, what's the width going to be and what's the length going to be. So we're taking this expression 4x squared plus 28x and we're saying, hey, can you figure out what one polynomial multiplied by another would be in order to get this area binomial? So all we're going to do is factor this. using common factoring. So 4x squared plus 28x, we're going to look at the common factor here. The greatest common factor between 4 and 28 is 4. And the greatest common factor between x squared and x is just x. Open up a set of brackets. 4x squared divided by 4x is just 1x. Right? 4 divided by 4 is 1. X squared divided by x is x. And 28x divided by 4x is going to be 7. Okay, good. So that's enough to tell us then that the length and width of this basketball court as expressions, right? The length is going to be 4x, and the width is going to be x plus 7. Right? And because this side is the same as this side, this is also x plus 7, and this side is the same as this side, this is 4x. So now we know the dimensions of the rectangle. To figure out an expression for the perimeter, all we have to do is add up all the sides, right? So we could say 4x plus x plus 7 plus another 4x plus x plus 7. So I'm taking all three of these, all four of these expressions and adding them together. So I have 1, 2, 3, 4, 5, 6 terms, but some of them are alike, and some of them are not alike. I'm going to put all my x terms together. 4x plus x plus 4x plus x. And I'll put my constant terms together, plus 7 plus 7. So an expression then for the perimeter, 4x plus x plus 4x plus x, that's 10x, right? 4 plus 1 plus 4 plus 1. Plus 7 is 14. So an expression for the perimeter is 10x plus 14. NLC just asks us, figure out what the actual dimensions are if x is 2 meters. So we said that the length, an expression for the length was 4x, and an expression for the width was x plus 7. Well, if we're going to substitute, if we know that x is equal to 2 meters, that has to mean that the length is going to be 4 multiplied by 2, which is going to be 8 meters. And the width would have to be x plus 7, so instead of x, 2 plus 7, which would be 9 meters. All right, so these would be the actual dimensions if we are given a value of x. Okay, so that's all for this lesson, and that's all really that I have ready for you for today. I'll stop sharing my screen to see if there are any questions.